Hello friends! In this video I'm going to quickly show you how to compute volume from a digital elevation model in QGIS. So a DEM is a raster or a grid of pixels. Each pixel value represents an elevation above sea level. If it's a projected raster, like it's in a UTM coordinate system, then each of these pixels is going to have the same area. And therefore we can visualize the DEM as basically a bunch of square, maybe rectangular pixels. Each pixel has the exact same length and width at the base, and they all have different heights. So we're going to compute the volume of each rectangle as length times width times height. Then we're going to sum up all the rectangles as an integral to estimate the volume. So in the real world, we're doing this on Mount Shasta, and we're interested in extracting the volume above the 1,880 meter elevation contour. So we're going to treat that as a reference plane. It's going to kind of act as a zero level for us. And we're going to visualize each pixel as an elevation or a height above that 1,880 meter contour. And again, our volume is going to be given by the sum across the whole study area of pixel length times width, which is the same for every pixel, times that pixel height. In this case, it'll be height above the 1,880 meter contour. Okay, so we'll quickly now go to QGIS. Here's our project. We've got Mount Shasta. We've got the 1,880 meter contour that we extracted in a previous video. And we also have a new DEM that we created by using that contour line as a mask. So for this particular masked raster, I can show you that we have elevation values inside and we have no data outside of the mask. So bear that in mind as we go forward. Also note that the mask is not a perfect tight clip to the contour. We have a little bit of scrap slipping in along the edges here. But it's still worth using the masked raster because it gets rid of a lot of other more complex topography. So the perfect way to do this is obviously using zonal statistics, the zonal statistics tool. And that's very easy to use. I recommend you to try it. However, in the lab that we have forthcoming, the Mars lab, that tool's not working. So I'm going to show you a bit of a workaround, in this case using the raster layer unique values report. And this is very easy. We just open that up, make sure we've chosen the masked raster, leave everything else at the default and hit run. And this is going to actually put out a little report over here on the right hand side. We can go click on it and it shows us all the stats. Notice here it's showing us the height and width of the full raster, not just the masked part. So be very careful using those in your calculation. It also shows us the total pixel count and the no data pixel count. So there you can estimate the percentage of actual data pixels is about 1/3. And you can actually use that information along with the mean elevation of the data set to get volume. But we're going to do it in a little bit even more of a circuitous way. We're going to just go down the list here and we're going to extract all of the elevation values above 1,880. So we're going to highlight everything and copy it into Excel. Okay, so copy and go paste that into a fresh Excel sheet. There's all of our numbers. Give ourselves some header. This is elevation in meters. This is number of pixels. And this is area in meters squared. So next thing we need to do is just actually subtract 1,880 from each of those elevations, because keep in mind we want volume above the 1,880 meter contour. So we can do that and then we can just click that down. So this is elevation above 1,880, and then to get volume of each rectangle, we would just multiply the total area times that elevation, and again we'll fill down such that this is now volume in meter cubed of the whole study area. And then we can simply use the sum function to sum all of those values And bear in mind, these values are going to be in meters squared, which is a pretty unwieldy metric. So we will probably divide that by 10 to the 9th to get into kilometers squared. So Mount Shasta has an area of 112.94 kilometers squared above the 1880 meter contour. This is a pretty workaround way to do this calculation. Again, in most cases, you could do this in zonal statistics by multiplying the average elevation times the basically number of pixels times area per pixel. Thanks for listening.